and welcome back to the SaaS community channel. With me today, I have special guests, both from Confluent. We have Pracheta, who is the technical lead on Elasticity at Confluent, Cloud Elasticity. And we have Ajit, who is a staff engineer who has been leading two very exciting Elasticity projects in the last year. So let's get started. And this whole conversation is going to be around Confluent Cloud really had this journey in the past few years from you get a fixed size cluster and this is life and you're stuck with it, to something that is almost serverless. You really size your cluster based on its usage. You have all the usage data. It's not completely serverless because you still have to expand it, but you can see the steps taken there. You can really do usage-based sizing and you can control the size of the cluster to fit what you do. And I'm having some guesses that you can kind of see where this road is leading. So obviously serverless experience is kind of the holy grail of cloud experience. Customers increasingly want to just pay for what they use, and to make it work, vendors have to make sure that they only provision what they charge for. So let's start from the user experience, since this is an experience that everyone wants. What for you is really great experience with an Elastic product?
I think if you ask me, for me, the first introduction to serverless was actually when I looked at AWS. They had this thing of Lambdas, and that was eye-opening for me, mainly because based on when the request arrives, they actually spin it up on demand. And that was truly an eye-opening experience. Like until then, it was like, hey, you run these VMs or you run even server instances, physical instances, and so on. And they could just be consuming resources. And this I think also opens up to this whole usage-based consumption model, right? Where, hey, I don't want to run these empty machines. And when I don't have anything that's like being produced or consumed in Confluent's use case, it's more like, why should I pay for those resources? And
a lot of it is really around capacity planning, right? Because if I cannot really grow and shrink on demand, I need to figure out what is the max I can possibly use in the next God knows how long, maybe a year, and just provision the entire thing, which is a lot to try to figure out, to be honest, in today's world.
Yep, absolutely. Yep. And when we look at like Confluent's kind of mission that Jay always keeps saying also, right, is how do you build this central nervous system that's kind of serverless and fully managed? And Confluent probably 2 years ago was on that journey, but we are still far away, where you had to provision these clusters, then you're stuck with it, like you mentioned. And we had to really look at many pieces in here, like from a customer viewpoint, what were some of the things that they really wanted when they looked at this whole expansion and shrink?
Yeah, and what did they really want?
Yeah, for them, it was more like, when I'm coming close to the cluster limits, how can I expand it? And how do I even know what's the dimensions that I'm coming close to? And I think this is where product and engineering spent a lot of time figuring out what are some of these dimensions that we can abstract out, and what are some of the dimensions that we need to expose. And that was kind of a hard exercise, because the more you expose, the lesser you become serverless. And you need to really expose the right amount so that they can make a decision also. Hey, I'm coming close to my cluster limits, or some dimension is being pushed. It means that I need to expand so that I can actually, come up with more increased capacity. And for Kafka's use case in here specifically, some of the things that were exposed are things like the ingress, the egress traffic, the partitions, and so on. But a lot of things were not exposed in terms of like how many brokers are we running internally. So, Confluent itself came up with this CKU dimension, like Confluent Kafka unit, which abstracts out like many of the pieces of Kafka itself and showcases some that helps you make some of those decisions. Hey, now is the time to expand your cluster. For shrink, it was slightly even more harder because we wanted to make sure when you shrink the cluster, the lower used capacity was able to satisfy your requirements. So, there were things like usage metric that we had to come up with and specify, hey, based on the current usage and based on if you shrink by X CKUs, what will be the predicted usage? So that the customer can make a informed decision that if I kind of shrink my cluster, it won't lead to like undeterministic issues or any issues that might crop up once they shrink the cluster.
Yeah, which kind of brings to really that you took on a lot of the capacity planning planes that otherwise a customer will need to go check the usage and trying to extrapolate from current usage like to a smaller set of servers. It's a hard problem.
Yep, absolutely.
Yeah.
And I think even satisfying these requests on demand, like there is a lot of capacity planning that these cloud providers actually do because they have all these growth numbers from different companies. They are able to extrapolate and say like, I want to get all these servers by this time so that I can able to satisfy customer growth. We had to do something internally as well so that we know, okay, based on the demand and based on the curve that we are seeing, how do we satisfy customer growth? And how do we satisfy these on-demand changes in resources? Like a customer might come in and say, hey, today I'm using 10 CQs, tomorrow I want 24. But we can't predict that. So we need to like make sure we have enough capacity so that we are able to satisfy these increases or decreases. The major thing is if we are not able to, one is it's a bad customer experience. The other is since we have moved to usage-based billing, it's like lost revenue for the company as well.
Yeah, very true. So we kind of, actually we talked about the experience without talking about a lot of details for the experience. So because there's part of the experience that are in the UI, like you go log into your cluster, it looks, you look at usage graphs, you look and you basically kind of play with the slider. I want it smaller, I want it bigger. And I think for a lot of customers, it was actually a fairly good experience. Like I remember talking to a few that are like, yeah, I'm a control freak. This is what I want to do all day. But I think there was also a lot of demand for automation. So you ended up writing APIs for this. So can you tell us a bit what in an API make it a great API for Elasticity?
Yeah, I think for APIs, it should be like as descriptive as possible. And at the same time, it should give them enough information to control these things, right? Like, so when we looked at these APIs, we had to tell them in a form that, hey, your cluster is currently ongoing. There's an ongoing operation in your cluster that's kind of going up or down. And that had to be exposed in the API as well. Mainly because like, if you're taking an operation, the cluster status should reflect that there is an ongoing operation. Most of the APIs kind of describe the current state, but this was a very intermediate state that had to be also exposed, which is kind of interesting, I think, for the most pieces. Like, for example, when you look at an Amazon order, it's not like your order is either placed or it's in the process of placing. Like, we don't expose they don't expose like your order is being in the process of being ordered or something of that sort. But there is a life cycle itself, right? Like you place an order, then it goes through like shipping, and that's kind of what is exposed in our APIs as well. And that's kind of like exposing the life cycle of the cluster. What is it going through? What is the current progress of the expansion too, like expansion or shrink in this scenario? And at the end, there are a lot of pieces that interact with each other. And that also has to be exposed both through the API as well as in the customer experience. So when the cluster expansion or shrink is complete, we kind of like send an email, we send a notification, we send a lot of things that says like, hey, now you have this added capacity. You can go explore that added capacity. So including APIs, we also have to think about like, how do you cover the customer experience in other forms as well, like through notifications, through other pieces that have to inform them about the activity in the cluster.
That's a really good point. I'm thinking, and maybe this is more of a question for Ajit, a lot of our listeners are engineers, and a lot of them are looking for really good tips on how to design APIs. I think this is something that kind of every engineer wants to get really good at. And kind of like, given those requirements to show specific things to customers, to create a certain experience, to really make things usable, how did you take those requirements and then turn them into an API? Like, I don't know, sources of inspirations, like basic principles that you work with?
Yeah, sure. I think so. One of the things that at Confluent that we kind of follow is it's like an event-driven paradigm, right? So from in all of these operations that we're trying to do are kind of long-running in nature. I mean, it takes I don't know, multiple hours to finish if you want to expand, depending upon the load you have on the cluster. And from an API interaction point of view, it's like, you kind of initiate an operation by issuing a request, and then, like Prachetaa was mentioning, it only makes sense to have another API through which you can like query and see what's the progress
get
that is
status.
Get the status part of it. So most of our operations, the APIs, operations that can be initiated by APIs kind of follow that same pattern. So there is this. I mean, if to borrow something from the Kubernetes world, right? So when somebody actually initiated an operation through an API, that's the desired state that they want. So that the desired state is actually recorded in our control plane, and then the control plane starts working on making the reality match the desired state. So it's kind of, so we have this like event-driven thing where at the control plane level we store the state, and then we in the background we asynchronously we kind of funnel this request down to the concerned data plane, which kind of interacts with the component.
So
let's say if you're talking about Kafka.
This sounds very Kubernetes inspired, and you are the second person to show up on this podcast to and tell me that they built a Kubernetes inspired control plane, and also that their APIs are Kubernetes inspired. Is that like the biggest trend in design patterns these days?
Yeah, I mean, it makes a lot of sense. It's a very simple pattern, but it's very very powerful, right? Like you can most of these things are inherently asynchronous, right? Like you need to have you need to stitch multiple resources together to give a whole experience, right? Like, and each of these individual resources have their own life cycles, and like how do you all line them up cleanly? So this Kubernetes pattern kind of makes a lot of sense there. So you have an overarching resource which kind of goes ahead and creates multiple sub-resources, and each of those sub-resources you can actually, this overarching resource can maintain the status of it, combine them all, and then present it as an overall status to the whoever is actually interacting with the system. So yeah, I mean that idea is quite powerful, and that's essentially what we have made use of.
I think
okay, sorry
to reboot, but I think one of the things that I also wanted to mention is even in the APIs, it's a lot of user experience that's involved in there, right? Which is when we look at many of the Kubernetes APIs, or even some of the APIs that people like, is mainly related to how quickly it responds to you.
Yeah.
So if an API takes like 5 seconds to respond, it hurts both the automation and the experience, right? So how do you quickly take the state that the user wants and give them the information that they want as soon as possible?
Yeah.
And then what you do under your house is your problem, but the house itself looks pretty, right? Like that's the major thing.
That's exactly it. We are going to talk about it in a second. I was just wondering, because you mentioned notification as part of the experience, and I think it's right that when something is async and can take many hours, having notification makes a lot of sense. And I do remember getting an email, your cluster shrunk, your cluster expanded. I remember when my team did it in a loop in a shared account over a weekend. So every few, I think it wasn't even hours, like it was multiple times an hour, my phone would go, your cluster shrank, your cluster expanded. So yeah, it's, I guess notifications are obviously a key part, but I was wondering, because we talked about APIs and we talked about notifications as a different thing, but what did you consider webhooks? I'll give you a URL, call this URL when you're done. It's good for automation. It can integrate with GitHub Actions, and it's kind of nice.
Yeah, actually, I think that I think we probably have such things in the roadmap. Currently, I think what we did was like originally, right, when we started off, there was a small email client that was there, and it would just go ahead and send an email to that. That was the only integration that we had. But now, like you mentioned, we are kind of like enhancing that part where you can have notifications via email, Slack. In fact, any other means that you need. So that kind of a thing is getting built, and it only makes sense, like from an automation point of view. Such things actually matter a lot. Like Prachata was actually alluding to the thing. Let's say if you take this specific Kafka Elasticity into account, so there is this metric that is sent out, which tells you the load, right? Based on that metric, you can actually automate your, you can get a auto scaling thing implemented. The customer itself can actually implement that. So so such things are powerful, and we are slowly moving towards that.
Or if I have a cluster, I can have like a nightly load test job that will basically call expand, wait for the webhook to say, hey, I'm done, and then kick off the job. Like it's very, automation is pretty cool.
Yeah.
Okay, so we talked about,
while we are actually talking about the experience part, there's one other thing that I think we also paid a lot of attention towards is the concept of billing, right? Like so when as part of Elasticity, I mean, the customer is either like asking for more resources or shrinking their resources, and we need to bill them accordingly. And so we also there was an experience kind of built into this whole pipeline as well, where when they're expanding, right, we would charge the customer only after they have expanded the complete cluster. Like in order to perform the expansion, there are multiple steps we do. Like we have to bring up the resources, and then we also need to balance the data out. So while the data is getting balanced, the resources are already spun up, and that means that from a cloud provider's perspective, we would be paying them, but we kind of hide those costs. Like customer won't see those costs until the cluster is completely expanded.
Which is amazing for usage-based billing, because literally until the resource is in use and technically utilized to serve your traffic and data, you're not billing for it. So exactly, amazing.
And the other way around is also the same thing. Like when they shrink it, we immediately drop the billing for the customer while we go ahead and clean up clean the resources. So it's one of the it's more customer friendly that way.
Yeah, absolutely. And I love how you highlight that billing is part of the user experience, because a lot of companies do not think about it that way, and it's incredibly noticeable that they don't think about it this way. And I never figured out, like, it's the same users also when they pay the bill, and to be honest, they're also slightly more cranky and sensitive when they pay the bill, so when they look at the bill. So it looks like the place to be extra thoughtful, and I kind of love that you guys were. So you mentioned that you're creating this amazing user experience, and even without diving into a lot of internal architecture of Confluent, it's very visible that there is a lot of components involved. Like there is the front-end UI, there are probably an API gateway somewhere, there are all the control plane components, there is Kubernetes, there is Kafka, there is the billing service, and I'm probably not even scratching the surface of what exactly is involved. And yet, it was literally your job to design a system that will be able to give this really unified user experience when so many components are involved, and the user should never has to care that, hey, billing was down, or it's Kubernetes was running into something. It should just all the error modes with all the components had to be completely abstracted away. Can you talk a bit about what kind of system did you design? How did you think about a user experience that spans component ownership? Because this is kind of rare. You don't read a lot about it when you look at system architecture design, and yet 99% of modern SaaS is one user experience, gazillion different components and microservices.
And I think like one of the things that come into play is, this event-driven paradigm, right? So when we spoke about how we take the state of the request and store it immediately, that's kind of our first layer of defense. Like that's where we need to do all of our checks that is required. So hey, it involves like some of the capacity planning that we talked about. Can we actually satisfy this request? Do we have enough resources available and stuff? Once we make these initial validations, which include like, is the cluster itself healthy? Like, is the load of the cluster under some limit due to which we can allow the shrink, or we are not too confident about the shrink and so on? Those are the major initial checks that we need to do, after which we kind of record the state of the request, right? And then this event-driven paradigm starts. Like, how do we take this request and make it a reality? You can think of it as some of the inspirations again from Kubernetes, because it's like Kubernetes does the exact same thing, takes in a desired state and then realizes using multiple components, how do you actually get to that desired state and match the actual state to that? So even when we were talking about these different components in play and decoupling these failure domains, like one of the major things, for example, let's take the notifications itself. The way we send a notification is not through like, an API, or we call a service, because that could fail and then you have to build in retry mechanisms and so on. But rather it's like, write the intended desire into Kafka, and then your service, the service that's supposed to send the notification, if it's unhealthy or whenever it becomes healthy, it can take that desire and do the needful, right? So you are decoupling these failure points using this event-driven paradigm. But if you actually communicate with each of the services, let's say there is a star model, right? There is one service that's driving this whole workflow, and that service has to talk to 10 different services to perform these actions. There is a possibility that it is going to fail somewhere. So you need to have a lot of retries. You need to keep making sure, like, maybe there is one service that's overwhelmed. Like, how do you make sure there's some back off also? But when you do this event-driven paradigm, all of these things are kind of inherently, come for free, I guess, in some fashion. And that's a really big win. And that's kind of what is in the heart of our, architecture itself.
A lot of people who design event-driven system, and I'm actually one of them, we find sorry, I'm trying to remember. There's two orchestration patterns. There is choreography, and then there is the non-choreographed one, which I forget what it's called. But the ones where kind of things happen more or less independently. I always think about it as like a jazz band doing improvisation, as opposed to the orchestra leader kind of telling everyone what to do at the same time. And a lot of them, people think that if you're event-driven, you have to just have events, services react to events without a centralized leader. Did you use this more of a jazz band pattern, or did you go with a more centralized approach?
So the thing is that I think there are some different flows where things would actually make sense, right? Especially for this update, where expansion and part of it, right? It's like, so there's only one desired state that is actually stored, and from there on, it kind of channels out. And for instance, like you need some amount of orchestration, right? Like you don't want to send a notification before things are done. So that means that there is a thing which is actually waiting for the actual expansion to complete, and only then that state is updated. And once it reaches a certain state, then the notification thing comes into play. So there's some amount of orchestration that would be needed amongst all of these things, because you need to line them up correcttly. Yeah. So does that answer your question?
Yeah, absolutely. Actually, I think this is an undocumented approach, and I don't know if you wrote about it, but people think about it as either or. And what you're saying is that the actual activity is the reactive pattern, but you have a centralized observer that watches the state and can therefore give customers, and even internally, I guess, if you happen to be on call, you want to know exactly the state of the system and not run around with 5,000 components to find it. So having a centralized state observer for this, I actually love it. I don't know how did nobody come up with it yet. And like the whole thing of separating what you do to write a system and what you do to observe it in general has been very powerful. Like I love Airflow, and this is also one of the things that I love, is that it doesn't make me use the UI to build a system, but I have a UI to watch it, which is all I ever really wanted. So yeah, this is fantastic. So we talked about you basically building across all those components. And obviously not all components are the same. Some components are more opinionated than others and more central to the user experience than others. And obviously if you have to expand Kafka, Kafka is a component that you really need to take its behavior to account. So can you talk a bit about how you design the system around Kafka's sensibilities?
Sure. Yeah, I think we can, in order to make this whole elasticity story quite pleasant, there's a deeper integration between what we call as the data plane and the Kafka cluster itself. Like, we are a Kubernetes shop. Most of us things run on Kubernetes, and even the customer's Kafka cluster will be running within a Kubernetes cluster itself. And we call that as the data plane, where customer clusters run. And within that data plane, we run a service which is called as the operator. Again, this is from the Kubernetes land. Basically, it allows us to extend the Kubernetes API. In Kubernetes, you have this controller pattern. You kind of define a resource, and there is a controller which manages that resource. And the resource tells you what the desired state should be, and the controller's job is to take the reality towards the to the desired state, right? So to represent a Kafka cluster, we use something called as the custom resource definition. We have a resource. It's a custom resource that we have, which encapsulates all the details of a Kafka cluster. Like, how many brokers it should run, what's the storage it needs, what's the networking story. So all of those things are encapsulated in that, right?
I'm going to ask you for a diagram that I can include in the video, because I don't know. I used to work on this.
I mean, it's very hand wavy and gestures. But yeah, yeah, in the Kubernetes world, that's CRD is a natural extension. Like if you want to manage your custom resources within the Kubernetes.
Okay. So basically, Kafka is a custom resource for Kubernetes, and you guys wrote this CRD to basically use the CRD to integrate with Kafka.
Yeah, exactly. So there's a service that would we call it as the operator service, because it's named after the Kubernetes pattern that is there. It's the operator pattern. So that's the within the data plane, that's the service that is responsible for managing this Kafka cluster in general. So when an expansion or a shrink request comes along, right? So let's say if we take the example of an expansion, we need to bring up new resources. And once the resources are all up, then we have to instruct Kafka to go ahead and perform the balancing act. Like we need to balance the load. And yeah, so this we kind of make use of the Kafka feature to perform this balancing. So this tight integration between the two. We have enough knowledge about the operator service has enough knowledge about how this component within Kafka works. Like, so that's one of the cool things that's there. I mean, we kind of make use of it. So what essentially it does is that in the expansion case, when you add new brokers to the cluster, this component running within Kafka knows that new brokers have come in, and it automatically initiates the balancing act. It kind
oh,
of
that's fantastic. So basically, suppose that putting the controls plane aside for a second, if you show up and do qctl and you deploy with this YAML that now has slightly more Kafka clusters, and basically the CRD, because it's very Kafka aware, will not just add the additional resources that my cluster definition now has, it will also call the correct APIs and everything that is needed.
Exactly. Yeah. So because the service that I spoke about, the operator service, would call the respective APIs in Kafka to handle this data management part of it, the data balancing part of it as well. So
and I guess you needed the Kafka APIs to kind of match the Kubernetes lifecycle expectations when you give Kafka a desired state and then you monitor for it.
So like if you're running within the Kubernetes world and then you're trying to manage certain components via APIs that are exposed by that component, like Kafka right? So there are certain expectations, like there are some design principles that we need to follow. So all of our APIs that we use to interact with Kafka are idempotent in nature, because things can change in the Kubernetes world, right? Like the operator, wherever it is running, because of any reason, the pod in which the operator service is running can get shut down and it can be restarted elsewhere. And that means that the long running operations that we do needs to be retried again. One way to do that is like you store enough persistent state that you exactly know which operation you performed, and then go ahead, which adds complexity to it.
Yeah.
The other part of it is like if you make your APIs idempotent, then you need not have that complexity and just start off.
I think like this is a very interesting point that Ajit is talking about, right? Which is actually during the API definition phase, we had to think about a lot of things. One is we had to understand how Kafka works, how the infrastructure that we are running in works, as well as the customer experience, right? So you have to combine all of these together. And then in the development phase itself, you define, hey, this is how the interaction should be. This is how the API definition should be. And it takes like immense amount of knowledge of both like the infrastructure layer as well as what is being deployed, like the Kafka here. Like KSQL is another example, which is completely different, but you need to know the depths of all of these pieces in order to actually deliver the customer experience we were talking about initially.
Yeah, and I love that it's kind of almost turtles all the way down. If you get to Kafka for those APIs, Kubernetes was the user in a sense. Like, so the CRD had to call those APIs. So you had to kind of work with the Kafka team to design APIs that will integrate well with the CRD, I guess. And they didn't know Kubernetes, so you really had to kind of translate Kubernetes thinking to Kafka thinking, and then you had to go and do the same for KSQL. So
I think all of our effort has also been to reduce the operations load. Like if you're not too careful about these things, like Prachata mentioned, right? Like thinking through the whole thing, you can actually have some ways of getting out, but your operational load will also increase. Like you might have to jump in manually and like tinker around stuff to set things up. So having these things like baked into the design kind of helps. It's a win on multiple fronts.
Absolutely. So we mentioned several times that you used Kubernetes to implement a lot of the logic, and a lot of things relied on Kubernetes in different places. And I think that at this point, we're in 2022, and choosing Kubernetes is not controversial. Like if someone needs to build something elastic, 90% chance they're not asking, should I use Kubernetes or not? They are going to use Kubernetes. And it's more about what should they expect after they use Kubernetes, because Kubernetes docs make Elasticity sound like it's a no-brainer. It's just built in. I don't have to even, nobody ever has to think about anything. I'm kind of wondering what, like, if we want to share with listeners, what are the gotchas that they may run into when they come to implement Elasticity for Pinot, Elasticity for whatever service they are running in the cloud, especially if it's stateful, but maybe even also stateless gotchas.
Oh, I thought Prachata would take that.
No, go for it, Ajit.
Yeah, I mean, I think I think one of the things that Kubernetes has solved for us is that it is also like a cloud provider abstraction layer for us. Like, we don't generally deal with like cloud provider APIs directly, right? Like mostly we deal with Kubernetes, and underneath Kubernetes would talk the right cloud provider APIs. So which is a big win for us, and like some of the things that I think problems that we come across with Kubernetes is also that one of the things is the storage management part of it. There is a notion of storage class, and we kind of define what type of storage we want, and it's most of those resources are immutable in nature. You can't change the characteristics of it. So for instance, like if you take AWS, right, like we are using different types of EBS volumes that AWS provides, and AWS constantly innovates, and they'll come up with newer types of
so
things.
let's say that you want to try, and what's the latest block IO2 block express, right?
Yeah. So things like that, it's very hard, like, because it's immutable, right? So the fact that I want to use a specific type of EBS volume is baked into a resource which is immutable. Like even though that underlying resource, let's say ABS, allows me to dynamically change the characteristics of my storage, you can't express that via Kubernetes, because the interface for you to use that resource is immutable. You can't change anything there. So that's a hard place to be at. Like there's some amount of operations load there. I wish the API. I mean, Kubernetes is trying to solve this problem for lots of vendors, right? Like it's not just cloud providers. So we kind of understand where Kubernetes is coming from. It's just that this is something that is kind of hard. We kind of get bitten by it very often. Like if you want to use something, it's some amount of work that we have to go through.
If I remember correctly, it's even that after the cloud provider announces a new type of storage, it's not always immediately available in their managed Kubernetes, or it's available but only with this machine type, this security setup, and you have to jump to install this driver, which has all those other requirements.
Yeah, and I think like that's also an interesting point where Kubernetes innovates very quickly. So you get like a release every 6 months or something, or 3 months rather.
Yeah.
And it's not very straightforward with stateful workloads to upgrade Kubernetes. Like you need to be very, very careful with how you upgrade Kubernetes and the node pools. And I think like some of the aspects, like as long as it's like stateless workloads, it's pretty easy. Like you can kill it, bring it somewhere else. It's pretty easy. But with stateful workloads, it gets harder. Like the way you use these persistent volumes and stuff, you might lose some flexibility. Like you might not be able to move workloads around that easily. So I think those are also some areas where folks need to be careful when they use Kubernetes. Like how do you do Kubernetes upgrades? And the cloud providers are pretty ruthless, right? Like it's hard for them to also maintain a lot of versions because it keeps moving along. So they deprecate versions and they expect you to move quickly. And based on the scale, it could become a large problem. Like for Confluent, it is becoming a large problem now.
I just remembered definitely one of the hardest Sundays I wasn't even on call, but I think I was pulled in to help a teammate. And if I remember, one of the cloud providers decided to upgrade Kubernetes, and they didn't tell us in advance. It absolutely caused downtime for our workload, which arguably is or isn't our fault, but we didn't think that they would do it without synchronizing with us. And then when we noticed that it's causing a downtime, we called them with a support ticket and we said, can you stop it? And they're like, no. Can you tell us how long it's going to take? They're like, no. Can you say that this problem is a result of the upgrade and not the new version, and therefore after you finish the upgrade we will be back in service? No. So it's definitely I do feel like the user experience leaves a bit to be desired, and in general, like I would say Kubernetes for stateless keeps getting better and better, and Kubernetes for stateful is hard, and I don't know if it's getting better all that fast. Does it get better?
We really hope it does. That also reminds me of an earlier issue. Like when I joined Confluent, one of the issues that we have is these managed Kubernetes are kind of a black box, right? It's the cloud provider's implementation. I think like people might forget, like most of the things that are there, like a service in Kubernetes, it can behave differently on GCP compared to AWS, compared to Azure. Yeah. So these things in general also give a very different perspective of Kubernetes, that it's not like the same experience everywhere. And we really hope like it can get more unified. It will get better because it becomes a pain in the sense that you need to understand somewhere like these are open source components that are deployed by cloud providers and they have custom implementations, and you need to take that into account when you kind of are using Kubernetes as well.
I
think the very basic resources are all easy. Like, standing up something is very easy. It helps us. Like we don't have to call any cloud provider AWS, but there are these gotchas here and there that you need to know about.
When we needed to mark an endpoint as ignore the health check or something like that, and I think we discovered that literally every single cloud provider interprets this slightly different. That was definitely a surprise. And like again, like as long as you do like the most basic stuff, there's no problem. But even in stateless, the moment you actually care about the more, I don't know, exotic annotations, and you want to try to have a bit more control over exactly how the load balancer will do things, you start seeing a lot of differences.
I think another aspect about running within Kubernetes, I think it's generally any managed service, I would say. But one of the things I think that we have, one of the services that we maintain actually, this is the online upgrade feature, right? It's a very essential one, because like let's say Kafka versions, we keep rolling newer versions of Kafka, and you have to do it across the fleet, and it has to be done in a controlled way so that you don't customers won't see any downtime. So the component that actually drives this thing is also very important. I mean, this needs to be baked into the thing
and we will have the owner of that component show up on this show. I already pinged him. I do think it's as I said, like it's a huge part of the user experience, like what happens when the vendor decided to upgrade. And I know Confluent's upgrade experience may not be 100% perfect, but at least I know when a customer calls and says, can you stop the upgrade, it's breaking things, we have stopped the upgrade in order to not break things. So we are on a slightly different, better situation than some major cloud vendors when it comes to
I think the automation layer is definitely it's very helpful. From a toil perspective it is, and I just kind of brought this up from a close integration point, from an integration point of view, like the operator service that is running, right? So that in order to perform this online upgrade, the operator also integrates, like it understands Kafka quite well, and it knows when to bring down a pod, a broker or not. So that intelligence is also baked into the operator service, and that is quite vital. Like having an overarching an automation to run these things across the fleet is very much essential. So is the case for having this tight integration with Kafka. Let's say, I mean, what I mean by that is like rolling a Kafka cluster versus a KSQL cluster is a completely different ballgame. So we need to understand what it takes to roll, and that intelligence is actually built into this this operator service that we spoke about.
Makes sense. Absolutely.
Yeah.
Yeah. So we are running out of time, and it's been fascinating, and you guys have a ton to share. I thought we'd finish off by, let's say that I have a cloud service that I'm currently building and still not telling anyone around it, but obviously I want to build it from day one to make it really elastic. And like, what is one tip that you would give me? Like, hey, we had to edit later, it was a bit hard. Think about this from the first day. Can you give me your best advice?
Oh,
yeah, you must have the things that you regretted not thinking about earlier. So
it's yeah, actually I'm not able to like formulate the thing properly. Maybe like Prachata, do you want to take a stab at it?
Yeah, I think like from the beginning, we really need to think about how different components are going to talk to each other. Like that
yes.
architecture needs to be in place and well thought out. Like, are you going with like, say, an event-driven paradigm, or are you going to do API calls across different services? And how is all of that feedback loop going to look like when you design different components, right? Maybe it's elasticity today, but also different pieces interact this way too. And how are you going to have all of that feedback loop coming back to the customer through the APIs? I think that is going to be the fundamental piece that will become harder to change later on. It's not impossible, but you know, as you have to disentangle maybe 100 services talking to each other, it is definitely a harder architecture than thinking through it at the beginning itself. And
it affects so many things. Like it affects your deployment strategy, your testing strategy. Like the moment you decide how will our services actually talk to each other and how will there surface errors up the stream, essentially. Like the moment you decide this, it determines 90% of actually what you're going to build. It determines everything.
Everything that we have talked about, like be it billing, be it events, be it anything. And also the first thing that we talked about, like the responsiveness of the APIs, right? Like if a request comes in and you're doing service to service, whatever way you want, you could get delayed responses, or you could get false errors and stuff like that.
It impacts latency, it impacts shipping, it impacts literally the productivity of the engineers who develop it, the stability of the system, and what the experience that customers actually have. Like you absolutely have to think about the whole thing. Yeah, that's a good one. That is a very good tip.
Yeah, completely agree. I don't think I could have expressed it well.
Yeah, and it may make sense to actually share one of the names your team had over time was workflow team. And like workflow really encapsulates that there is a single experience that just spans a lot of components. And the moment you think about how will those components work together, you designed a general purpose workflow that then you just, every other workflow after you figured out the general blueprint of a workflow would be a lot easier because you agreed on the deepest things.
Yep, absolutely.
Yeah, awesome. So Pracheta, Ajit, I learned so much, which is just joyful for me because I worked with you for 2+ years, 3+ years, and still every time we talk, I'm learning something new, which is absolutely amazing. Yeah, and thank you so much for being here.